Hello, dear students. Today we have Proposition 44, Book 1, Proposition 44. To a given line, in a given angle, to construct a parallelogram equal to a given triangle. Sounds complicated. It's not really. Here's our given line, here's our given angle, and here's our given triangle. The enunciation states, to a given line, in a given angle, to construct a parallelogram on that line, equal to a given triangle, okay? Here's our line, here's our angle, here's our triangle. Thus it is required to apply to this line a parallelogram that has an angle equal to this angle and the area equal to this triangle. Okay, so let's look at our bag of knowledge. Today we're going to use our previous proposition, which says we can make a parallelogram equal to a given triangle. We're going to rely on the fact that we know that alternate angles of, when you have a parallel lines and a straight line falling upon them, it creates alternate angles equal to each other. From a point not on a line to draw a line parallel to a given straight line, we're going to do that, rely on that. And then we're going to remember from the previous proposition that the complements about the diameter in any parallelogram are equal to each other. Okay, so let's get cracking. Let's continue this line here indefinitely. Okay, and let's construct in this angle. Let's see here, how do we want to do this? Let's make, let it be, we know we can make a parallelogram equal to a given triangle in a given angle. Okay, so let that be. Let it be this. Okay, remember, the intellect sees that it can be done already, so it demands of the imagination, give me one. So the imagination is going to do that. And the intellect saying, apply it to this line continued. Okay, so we'll use a different color here. Apply it to this line continued, and let it be something like this, and let it be about this big, say, just to appeal to the imagination, and let it be in this angle, which is equal to this, okay? So we're going to make that parallelogram. So remember, we already know we can do that. Given a triangle, we can make a parallelogram equal to it using a given angle. So here we say, let it be done, boom. And let it be this, with this being the angle. So now it has the angle equal to it. And let's apply it to our given straight line continued, okay? So we continue that straight line, and we take that parallelogram and we say, boom, apply it so that the line of the parallelogram, the base of the parallelogram, is contiguous with this straight line continued, okay? Great. Now let's continue with the proposition. What we'll do first here is we'll continue this straight line. Okay. On this line, from this point, we'll draw a line parallel to this line. Okay. Parallel to this line. So it meets this. It met this line continued. We continued this line. Okay? Let's now connect these 2 points. See this point and this point. Let's connect them. Okay? And let's continue this line. And let's continue this line until the two meet. Okay? What do we have here? Right? And from this point, let's draw a line parallel to this line. what have we have here? Neat color that we haven't used yet. Blue. Remember, we can do that. Given a line and a point not on it, to construct a line parallel. Okay, and let's continue this green line. They meet. Okay. All right, and let's continue this line. Great. All right, now this is a complement of this. Look at this parallelogram and this diameter. And we've proven in the past that the complements about the diameter are equal. So see how these are the complements, because here's the diameter and they're just touching the diameter. And these things are the parallelograms that surround the diameter. These just touch it, those are the complements. So this is equal to this. But this is equal to this. So now we have two things equal to the same thing. They're necessarily equal to each other. So here's a parallelogram applied to the given straight line equal to the given triangle. Pretty cool, huh? And then now we just need to show that it has an angle equal to this, and we'll be done. So look at these, let's see, we have this line and this line, with this line falling upon them. So it creates alternate angles equal to each other. Remember that? We've proven that if you have two parallel lines and a straight line falling upon them, the alternate angles are equal. So in this case, you have that line's going this way and the parallel falling like that. So this is equal to this. Here we have, let's see, this line falling upon, let me see, I'm going to make sure I'm doing that right. That's not right. That's not right. Let me see here. I've got these two parallel lines, so it's this. Sorry about that. Notice how I mean, I don't want to brag here, but I didn't just will it to be so. To me, I couldn't see why it was so. Now I see why it's so, because here are two parallel lines, and here's a straight line falling upon them. So it creates alternate angles equal, okay? So now here we have alternate two parallel lines. Here we have two parallel lines, and this straight line falling upon them, creating alternate angles equal, okay? So this is equal to this, because we have two parallel lines and a straight line falling upon them, creating alternate angles equal. And this is equal to this, because we have two parallel lines and a straight line falling upon them, creating alternate angles equal, okay? So if this equals this, and this equals this equals this. Two things equal to the same thing are equal to each other. But this equals this. Now we have two things equal to the same thing. They're equal to each other. So this angle necessarily equals the given angle. Okay, so here we have this parallelogram which we've constructed on the given line that's equal to the given triangle. We prove that. And it has an angle equal to the given angle. Quod erat faciendum, which was to be constructed, which was to be made, okay? So to repeat then, on a given line and in a given angle, to apply a parallelogram equal to a given triangle. We did that first by relying heavily, say, on the proposition where we were able to construct a parallelogram equal to a given triangle. So we got that parallelogram, and then we applied it to our given line continued. Okay? And then we just made the figure, continued with the figure, making this parallelogram. And then we made our transversal by continuing lines. And then we made this. Then we ended up coming up with this. And then because this is equal to this, because they're complements about the diameter, and this was made equal to this, we have two things equal to the same thing, they're equal to each other. So here we've done the first part of the prop, the parallelogram equal to the triangle. And then we just need to show that in so constructing all this stuff, we happen to have made an angle equal to the given angle. Why? Because these two are alternate angles, therefore they're equal to each other. And these two are alternate angles, therefore they're equal to each other. So two things equal to the same thing. These two are equal to each other. But this is also equal to this. Two things equal to the same thing, they're equal to each other. Therefore, this angle is equal to this angle. Therefore, this parallelogram is applied to this given line, and it's equal to the given triangle, and has an angle equal to the given angle. I just wanted to redo that because it can be a complicated problem, but I think when you do it a couple of times, it'll be pretty easy. If you get good at this, then you're really on your way to becoming a Euclidean god, okay? Or goddess. So thank you so much for your time. God bless you.